Let's get to some proofs now with recursion. So, in general, closed forms of sequences are nicer than recursive ones. So, yes, we can define sequences in two different ways, and they have their pros and cons. But in general, if you're trying to fully describe the sequence, you like to have a closed form because then you can just plug in any n value and you can get any number in the sequence that you want without having to find previous ones. So our goal then is to figure out how do we prove that a closed form is the correct one for a recursive sequence. So how do we do that? How do we show, based off of that previous theorem, that there is something that works? So if you look at that, if you think about what we have going on with this sequence, you have this initial, and then you have future terms that are dependent on other terms with the recursive thing. So you should be thinking that we must use induction. We're going to use mathematical induction as a way to prove that the closed sequence is indeed the correct sequence. So this previous sequence that we worked with, b sub n plus 1 is 3 plus 2 times b to the n, or b sub n, and b sub 1 is 4. Then we like to prove that this is the closed form, that b sub n equals 7 times 2 to the n minus 1 minus 3 is the closed form for all natural numbers. So we'll do our proof by induction. So we have our proof. The first thing we always have to prove with induction is the base case. So we have our base case. Our base case, in this, what we're trying to show with the base case is that the initial condition is true. If we had more than one initial condition, we actually have to show that all of them are true. So we might need more than one base case. But in this case, we just need one. So we will say let n equal 1. We're trying to show that plugging in n equals 1 into this closed formula gives us what we expect it to be. So notice we have b sub 1 is equal to 7 times 3, or 7 times 2 to the 1 minus 1 minus 3. But that's just 7 times 1 minus 3, and that's just equal to 4, which is perfect. That's what we wanted. We wanted to show that the first term was 4. Cool. Now we have our induction step. So our induction step is we will assume that this formula is true for n. So we will assume b sub n is equal to 7 times 2 to the n minus 1 minus 3 is true for n. We would like to show that it is true for n plus 1. So what that means is we'd like to show that b sub n plus 1 is equal to 7 times 2 to the n minus 3. So this is what it looks like. If you plug in n plus 1 into there, you get this expression. So that's what we'd like to show. So now again, we work with the induction hypothesis and figure out how can I get to this conclusion. So we assume the induction hypothesis is true, right? We assume that that's what this is. But we also have the recurrence sequence. If you're not using the recursive sequence, then you're probably not going to prove it correctly. You need to use both the recursive sequence, as well as the induction hypothesis. So notice we have b to the n plus 1 is equal to 3 plus 2 times b to the n, which is equal to 3 plus 2 times 7 times 2 to the n minus 1 minus 3. And then now we just work with this to figure out what does b sub n plus 1 simplify to. So I have 3 plus 7 times 2 to the n minus 3, or minus 6. And then by subtracting those, I have 7 times 2 to the n minus 3. So we have indeed shown that b sub n plus 1 is equal to that. And then hooray, that proves by induction that the closed formula is given by this. So then by induction, b sub n is equal to 7 times 2 to the n minus 1 minus 3 for all n in the natural numbers. And that's how you prove that the closed formula worked for a given recursive formula.